Hi, and welcome back to, again, this lengthy introduction of conic sections linked to calculus, polar, parametric. What we're going to discuss in today's lesson is we started with the ellipse. We went through that loop with calculus, polar, and parametric. We're going to end up with real-life application like we started of the ellipse in polar, in Cartesian, and in parametric. But first, we're going to study in this lesson, how is this squish? Remember, this is the auxiliary circle. This is the circle that has the same center as the ellipse. And here, horizontally, if the ellipse is stretched horizontally, if it's stretched vertically, it's going to happen the other way. How is that auxiliary circle? How does that squish happen, and how do we draw the ellipse? And why and how is that squish related to circles in general? Which circles? Auxiliary, concentric? Is it also related to the director circle, which is the locus of all those intersection of the perpendicular tangents to the ellipse? We will find out. We're also gonna, in this lesson, hopefully, we're gonna go back to the famous remember the string loop and how the length of that string loop doesn't change, and that's why pf plus pf prime is a constant. And in order to define many of these ellipse rules and formulas without memorizing them, we're gonna pretend, what if that p here, this is your f or f prime, or that's the other one here. What if this pf plus pf prime is at the vertex? What if p, because sometimes it's a moving point, right? That's a conic section, the point moves. What happens when p is here? Can we derive the formulas? Can you understand it better? And this way you won't need to understand all the formulas. What are the a's and the b and the c and the a divided by e and the e squared? And we already know that e, eccentricity for the ellipse, this is my P, big P, with XY. This is my F, and the PF is way smaller than PM. That's why E is a fraction. It's a proper fraction between 0 and 1. Okay? Now, how did I get to, also we might, if we have time, how did I get to this x minus h squared divided by a2 plus y minus k squared divided by b2 equal 1 as the general formula or the standard formula of an ellipse? Remember, the general formula is the conic section formula. Ax squared, there is no b, plus cy squared plus dx plus ey plus f equals 0. And a, the only thing I told you need to memorize for an ellipse, is not equal to c. A times c is positive, is larger than 0, is greater than 0. Okay? So without further ado, let's start with how is that squish related to circles? Now, if you have an auxiliary circle, what is any circle at an origin O, 0, 0, okay? What's the equation of the circle? X squared, after you expand this, ax to x squared plus what? Y squared equals, instead of r squared, let's call it a squared, okay? Let's keep this r equals to a, which is the focal radius of the ellipse here. Okay? That's all I'm asking you to do for now. This r, instead of r squared, I'm gonna do a squared. Okay? So if I am to, shift it from the origin, from 0, 0, I get x minus h squared plus y minus k squared. Very simple. Equals a squared. All agree? Okay. James? Yeah. And then all I do is just divide. If I want to divide by what? By a squared. What do I get? This becomes 1. Okay? That's why sometimes, I have the circle written like this. All I did is just I moved this because I divided the other side of the equal sign by the r squared or the a squared in this situation. Well, for this same auxiliary circle that it has the same center as the ellipse, the equation of the ellipse looks like this. It's almost the same, except there is a B2. And what's that B2? This is B, this one, the minor axis, radius squared. So that's the squish. Now, how is that squish related to the auxiliary circle or to any circle? Or is it related to, let's think, is it related to concentric circles? I don't know. Let's find out. Let's take two circles. I have them on the board. I'm going to go to the board in a second, but I'm just going to tell you what I did quickly here before we go to the board. So I took two circles. The first one with a radius 3. So this is 3. Okay, and 3. You know what? That's not going to work this way. Let's make this the 5, and then we'll squish the 3. So let's make this the 5. Let's pretend this is the 5, the outer circle. Okay, that's all I did. You join it like this. And then I took an inner circle with the same center, and with a 3 centimeter. So let's take it's 3 centimeter, 3 centimeter, 3 centimeter. So these look like what? Like concentric circle. Exactly. Yes. The first R here is 3. The second one is 5. But the outer circle is not the director circle here. How do I find the director? The inner one has x squared plus y squared equal 3 squared equals 9, right? What is the director circle of a circle? Remember, you do times 2r squared. We just did it in the previous lesson yesterday. X squared plus y squared equal 2 times r squared. 2 times 9 equals 18, right? And you have a new radius of this director circle where the locus, the set of point of the intersecting point of the perpendicular tangent, you have a new radius equal r, original r, which is what? 3 times square root of 2, right? And square root of 2 is 1.4142, so that's almost around 4.25, 4 1/4. So it's somewhere here. So the 5, the outer circle, is not actually, the director circle. Those are just concentric circle, sharing the same origin O here, okay? One has a 3 radius, the other one has a 5, 3 centimeter, 5 centimeter, 3 inches, 5 inches. That doesn't matter. That's not the idea. So the minor axis now, look, we're going to draw the ellipse, and we're going to find out that the squish is going to make the minor axis as what? As the radius of this inner circle, okay? Now, if, how do I draw this? We're going to go draw it on the board. We're going to take from the outer circle. So we have two concentric circles, okay? And I'm going to go to the board. Okay, all I did was, this is my 5 centimeter. This is my 3 centimeter inner circle. This is 3, this is 5. And like I said, we found out if I want to get the director circle, that means where what? Where the perpendicular, like this. See this? Tangent, perpendicular. This is what we did in the previous lessons. Everything is, again, interlinked. They meet at a locus or set of point where r equal square root of 2 times the original radius, which is 3. 3 times 1.4142, it's around 4 1/4. It's around 4.25. So you get this director circle here. So this bigger circle, 5, with proportions 3, 5, it depends on the proportion. We're not going to go into the proportion. We're going to go into the proportions and how the director circle and the tangents, they need restrictions, and they need to be proportional later on, by the end of this introduction. Now we just want to draw the ellipse, okay? So all I did, I made 12 marks. See, I cut this circle, the two circles, the two concentric circles, into 12 marks of equal, sectors. I can cut it into more to make the ellipse, to draw the ellipse and to sketch it the correct way. And I'm going to show you how. I did that on a piece of paper. Okay? So basically all you need to do here is from the outer circle, you draw a vertical line and a horizontal line from the inner circle. And where they intersect, this is where the pulling and the tugging. Remember when we had the string loop and we taught it by dragging the pencil? This is the dragging of the pencil is going to happen here. Look, vertical from the outer and horizontal from the inner. And they intersect perpendicularly. Right where they intersect, vertical, horizontal. At the 90 degrees, this is the point of intersection. Here, look. Here, what happens? That's the main idea, the main point. Here, they're going to meet right there. So, this is what? If you keep going, look. And I take vertical, and then I take horizontal. And then I join these points. Okay, and then here you also take horizontal. Okay, and then you take your vertical and you meet right here. You got the idea. Okay, so here and here they meet where? They meet right at exactly, yes, right at where R of the inner circle is gonna equal that B. So the squish happened keeping A, look at A. Sorry, this goes like this. Keeping A as R, so A equals R of what? Of that concentric, outer concentric circle. And B is gonna equal, after the squish, the radius of the inner concentric circle. So all I did was, at this point, if you draw your vertical and your horizontal, you're going to end up right here. And here, if you draw your vertical, you cannot draw your vertical or your horizontal. You're going to meet right at that point. Okay? So the squish is going to end you right at the radius of that inner concentric circle. However, the vertical and horizontal are going to meet right at the radius where the radius of the outer concentric circle. Let me get back and show you this, how I did that on a piece of paper. Maybe you can look at this. You can take more marks, of course, and if you take more marks, it gets better, okay? It's get better and better. Look at this. That's what I did. Look at this. The more marks you make, see how I made the semi-ellipse, and I drew, and the squish happened? For the one that you have on the board, that's what I did on a piece of paper. You got it now? See it, James? Okay, so 3 centimeter, 5 centimeter, and then you take your verticals, from the outer, your horizontal from the inner, and right at the end, what do you get? You get that ellipse with the radius of the outer concentric circle staying as A, and the radius of the inner concentric circle, which is the 3, becoming the B of the ellipse. That's the whole idea about how we sketch a semi-ellipse or an ellipse in general. Okay, so if you are to sketch it and to draw it, or in a pre-calculus or in a calculus 1 curriculum, basically you will be asked and to understand that an ellipse is drawn by drawing 2 concentric circles. You need to understand that and know that the B, this B, they have the ellipse for you like this, stretch horizontally, and it's stretched this way in most textbook. And so far we know that this is 0, or the center. This is F, it's equidistant from F prime, so this is F prime, they're equidistant. You know that OA, so far, OA equals A, right? That's the radius of the outer concentric circle. And if I call this B, big B here, OB equals small b. What is the small b? That's the radius of the inner concentric circle. This is how I squished, and this is the amount of this squish. That's all we did. It's the amount of the squish. So, and you squish it from one concentric circle to, an inner concentric circle. That's all we did. Now, let's go back and, explain how not to memorize any of these A and B and C and D. Let's draw, let's make this the y-axis. And let's make that the x-axis. As a matter of fact, let's go to the board and do that at the board. Okay, so let's go to the board. My favorite tool here. Okay, so if I do have, we're not talking about polar now, we're just talking simple rectangular coordinates, Cartesian grid, and I have y and x axis, and I have the ellipse right at the origin at 0, 0, just to make it easy for now, just to get the calculations. And I have my first, f or f prime equidistant from that center right here. I don't have an h and a k so far. I'm not shifting it. I'm making it right at the origin just to get the calculation going, okay? So the slack, and let's call that, let's make it like this and like that. So far, what do we know for the ellipse? You know that has a general conic formula that goes like this: plus cy squared plus dx plus ey plus f equals 0. A not equal to c, and a times c is greater than 0. And then so far you also know if you take a point P, remember the string loop, and you do PF plus PF prime, so that's PF and PF prime. So we got 2 points. We got PF and PF prime. You can call it PF1, PF2, you can call it PF, PF prime, it doesn't matter. The order does not matter, okay? So let's call this F prime, and let's keep that at F right now, so we can make our calculation. So far we know that PF, this PF, plus PF prime equals a constant. Wherever that P goes, if P is here, that's what we're going to study now, or P is here, or here, or here, or anywhere, the PF or QF plus QF prime, or WF plus WF prime equals a constant. Now, we call that the focal diameter, or the focal, this from O, let's call that big A here, and this is big B. And let's call that A, B, C, D. AC is your focal diameter. OA is your focal radius. A is the vertex, the major vertex. C is a major vertex. B and D are what? Are minor vertices or co-vertices in some textbooks. Okay? So basically OA is this outer concentric circle radius. It's the small a. And OB is your B, the inner concentric circle small radius, okay? Now, what is OF prime or OF? What is OF prime, James? Text? Yes, this is plus C. So this is C, and the Y is 0 in this particular situation. So, because it's stretched horizontally, and this one is what? Is minus C and 0. In most textbooks, the F, the foci, are at C. The C is associated with the foci, with the focus points. So this is the small a, this is the small b, this is the small c or minus c, depends on where you are, okay? In most textbooks, this is what you get. Now, we're gonna start, digging into this. Sometimes this is written as A times E, eccentricity and 0. And here we have minus a times e and 0. And why, and should I remember it, should I memorize it? We will talk about that in a few minutes. And then where is the directrix? On this side, remember there's a directrix. You know, we can take, if P is here, right? You take what? You take the directrix. It's the same concept. This is a conic section. And PF here is smaller than PM. And in this situation, the directrix is going to be equal, x equal what? X equal A divided by E. We're going to explain why and should you memorize it, yes or no. The one on the other side is going to be equal x equal minus A divided by E, E being the eccentricity. There is more to this. Where is the latest rectum? Remember we did the latest rectum with the parabola, and we said this is in Latin, it means side or line straight that passes through the focus and is straight parallel to this directrix, to this fixed line. So this is going to be your latest rectum on this side. There's another one here on that side. So the coordinates of that latest rectum, the x is going to have the same coordinate as your focus point, whether it's C or AE, A times E. The y, we will figure out that, and I will explain to you how to get the y and y. It's just a point on the curve, so you can plug it into the equation of the ellipse, which we will talk again why we have this a2 under the x and why we have the b when it's stretched horizontally, y minus k, I'm sorry, squared divided by b squared equal 1. Okay, so in general, in most textbooks, this is what you see. Okay, so far, just memorize this for me, because when we do the hyperbola, you're going to understand why a times c is negative. And in this situation, you know, you will never forget it, and it will be, you know, it won't be a thing to memorize for you. This one, we explain it with the string pull and the length of the string pull that doesn't change. The A is the radius of the auxiliary circle. The B is the radius of the inner concentric circle where we made the squish. Now, look at that. AF prime and CF are the slack. Remember when we talked about the carpenter? And he was cutting this oval elliptical tabletop. And we call that the slack. And we said that CF equal AF prime. Since the two foci are equidistant, this slack is what? The slack is also, you know, equal in magnitude. This one is going to equal to this one, and this one is going to equal to this one. However, look very carefully. In any ellipse, this is A, small a, and this is small c, right? So what is the slack here? A minus c, right? In the same way, you know, the small b squared, the squish is a squared minus c squared. But this is not the Pythagorean theorem here. Because if you take Pythagorean theorem and you do like this, a squared plus b squared equal what? Equal this distance here. But the slack equals a minus c. But if you square a2 minus c2, you get your b, this small inner circle, inner concentric circle radius. So the squish, b squared, is going to equal a2 minus c2. This means that b is minus than a in an ellipse. Okay, this is the thing that you don't need to memorize it. It's b is, you know, smaller than a because you did the squish yourself. And once you understand that b is smaller than a, it's the slack squared that makes that. It's not the Pythagorean. We will dig more into that either in this introduction or with calculus. This is not a Pythagorean theorem. A minus c is your slack. A squared minus c squared equal b squared is this minor, the minor axis radius, or the radius of the inner concentric circle where the squish happened. Okay. This b squared equals a squared minus c squared. I personally don't memorize it. If you're going to start in order to get everything here, in order to get that this is equal this, and C equal A times E, and in order to get most of these formulas and rules, we're going to start with this. B squared equal A squared, the squish. Again, and because it's a squish, I know that B is less than A. And I know that this is not the Pythagorean theorem here. I'm not dealing with the Pythagorean theorem. I'm dealing with the opposite of the slack on the other side, where the squish happened. So instead of A minus C giving me the slack that the carpenter left, I go B squared equal A squared minus C squared. Okay? This one, if you want to memorize it for now, let's memorize only this one. We're going to derive more and more and more rules and formulas out of this one. Okay? And let's go back to our tablet and let's see if we can start actually digging and deriving some of these formulas. Yes, the first one we're going to deal with is we're going to keep the same here. Ellipse at the origin, make it easy, call this, like we said, F prime, and this is F, okay? We're gonna call this is your A, and let's make this B here. And let's go like that to make it easy. So I have F prime at what? F prime, James, can you, okay, C0 so far. Very easy. And I have F at what? Minus C0. Okay, perfect. Now, we said this is the focal radius. Okay, and the whole thing is a focal diameter. So the sum of the focal radius or focal radii, here we speak about foci and radii, is what? A plus A. It's 2A, right? I want to find out what that 2A, or the diameter, the focal diameter, or the sum of the focal radii. Remember in a parabola, I didn't have that. In a parabola, what did I have? We had this. We had the focus, one focus, center at the focus. And I had that distance between the F and the V equal what? Equal the small p or the small a in some books. And we call that focal length or focal distance. Here we have a focal radius or a focal radii. In some books, we're going to see why it's called focal length sometimes and how do we use the focal length. But for now, let's keep it as focal radius, you know, linking that to the circles, to the concentric and auxiliary circle. Now, the distance from the focus point F to the vertex A0. Where's A0? Here, this big A has what? A0. So the distance from F, this F here, to AF is what? Is A, the X coordinate, right? Minus C is A plus C. Look at it. Is that magnitude C plus A. So AF equals A plus C. And then the distance from A to F prime is what? Is A minus C. You agree? Okay. So it equals AF prime equal A minus C. So AF equal A plus C. And big A, AF prime equals A minus C. So the sum of the two focal radii equals what? Here, let's do it on the board. Let's erase some stuff and let's do it on the board, because this is very important, okay? So, let me erase some of that stuff here. So I'm just keeping this one, the one I told you is super important. B squared, the squish, the radius of the inner concentric circles equals A squared minus C squared. If you just take A minus C, you get your slack. But A squared minus C squared gives you the B here, okay? B squared, I'm sorry. So what I'm doing right now is I'm looking at this distance. AF equals what? Equals A plus C, or A minus C. Remember, this is minus C0, the magnitude, the distance is C. And AF prime equals what? Equals A minus the C. A minus C. So AF plus AF prime equals what? Equals your sum of focal radius or radii, okay? Equals A plus C plus A minus C. So equals what? 2A. Oh, look at that. Equals 2A. So if that point here, A, is not at A, if it's at P, if it's right here, if it's PF plus PF prime, that's going to equal what? It's going to equal 2A, I'm sorry. And that's the first rule of your ellipse, that, you know, oh, I have to memorize PF plus PF prime equals 2A. No, you don't have to memorize it. See how we derive that? When this P is moving, right? It's a moving point on a conic sections. That's why we use conic sections a lot in calculus. They're moving point. They're in constant movement and change. So when this P is right here at A, what happens to PF plus PF prime? It becomes AF plus AF prime. And we just figured out that AF is A plus C, AF prime is A minus C. If you add them up, you get 2A. I never memorized this one, and you should not memorize. You should never memorize it. It's 2A. You need to understand that the point on the ellipse on the conic section is going to be moving. When it's right here, that means it's 2 times that focal radius, or 2 focal radii. Okay? The only thing just you need to keep in mind for now is B squared, the squish, equals A squared minus C squared. Okay? All right. So having that in mind, let's dig more into more rules. There are a lot of rules and formulas for the ellipse, and one is, you know, derived, and it comes from the other. You know, it just here. Let's one of the here. I believe, yeah, you, Lisa, you asked me about that. Okay, so we, in the beginning, our the general formula for an ellipse was in this form, right? Like this. AX squared plus CY squared plus DX plus EY plus F equals 0. And then we did A is not equal, right? Exactly. A is not equal to C. AC is more than 0, larger than 0. It's positive. This is an ellipse. Now, we also found right now that what? That these two distances, this distance here, the distance here, PF, this is distance 1, PF plus PF prime, so D1 plus D2, the distance from any moving point on that ellipse to the two foci equals what? D1 plus D2. Or PF plus PF prime, or AF plus AF prime. So D1 plus D2 equals what? Equals 2A. Okay? Now, I'm not going to go through the whole thing because that's going to take us like 10-15 minutes. To square, expand, isolate, square factors, rewrite, and do all that stuff. And I'm going to show you how these form, you don't need to memorize this, how this formula is derived. This shape, x squared over A2 plus y squared over B2 equals 1. Okay? So if we start with something as simple as what we just said, D1 plus D2 equals what? Equals 2A, right? What's D1 and plus D2? D1 plus D2 equals, this is a distance formula, equal the square root when you have a distance formula, exactly. X minus, if, you know, this is, look at this. So you won't tell me where did the X come from. This is a point moving here, so it has an XY, that's it. Any point moving, remember, even on the parabola, it's not r, theta, we are in regular Cartesian, it's XY. So when I do distance formula, I do X, and then the first, if this is D1, if this is minus C right here, this F is what? Minus C0, and this one is plus C0, right? Okay, so that's X minus C, the whole thing squared, exactly. And then plus Y minus 0 squared, plus the other side, you know, X, not minus C, just minus C squared plus Y minus 0 squared equals 2A. So far, so good, right? Okay, now I go inside and I simplify. If I simplify, I can do it like this. I can do, let me see here. this is x plus c inside plus y squared. Let me put all that together under 1, like this. So I can do x plus c squared plus y squared, right? And yeah, I can put all that, and I can, on the other side, put the 2a, and then move this one. See this one here? I'm going to move it to the other side. So let me go to a new page. So now on this side, I have this. I have x plus c squared plus y squared. And on the other side, I have 2a, and then I moved this one here. The x minus c, not the x plus c. X minus c squared plus y squared. Okay? Simple as that. Now, I want to square both sides. There is no calculus here. There's nothing difficult. Just hard, tedious work. Math calculation and squaring and expanding and eliminating. Squares equals square. That's all I did. Now, if I want to get this out, what do I get? I get x squared plus c squared plus 2cx. I did that so I can get rid of that square root plus y squared equal what? 2a squared equals what? 4a squared minus 4a times the square root, right? X minus c squared plus y squared plus this one squared, x squared minus 2cx plus c squared and plus y squared. Okay, I got it right, I believe. Yes. Now, I expanded it. Now, what do I need to do? I want to isolate, and let's keep the a's on one side. So if I take, what was that one here? Let me see. I have 2cx. I can keep the 2cx. Okay, and look at that. This, and this, and this, and this, right? And this, all bye-bye. Okay, so I can keep the 2cx on this side. I can keep 2cx equal 4a squared. You understand where I'm going with this. Square root x minus c squared plus y squared. Okay, this is under the square root minus 2cx. Okay, so if I bring, let's say here, okay, I isolated, I want to divide now. Before I divide by 4, minus 2cx, that's 4cx on this side. Okay, minus 4a squared is going to equal what? Minus 4a. So I isolated the radical, this radical here. X minus c squared plus y squared. Okay, so now if I divide by 4, I get rid of the 4's. I get cx minus a2 equals minus a, and this whole thing. Now, I'm not going to keep going with this, but you get the idea. Now, all I'm going to do at the end, I'm going to keep squaring, factoring, dividing by a squared, moving it to the other side. This is how I got my 1 equals 1. And then you get rid of your c's in the same way. And then at the end, you're going to end up with this. Just long, tedious work that you don't need to memorize. X squared divided by a squared plus y squared divided by b squared equals 1. You get rid of the c's, basically, okay? And if it's, if it's not at the origin, it's x minus h squared divided by a2 plus y squared divided by, y minus k squared divided by b2 equals 1. Okay, got the idea? Okay, so we used this d1 plus d2, pf plus pf prime, or af plus af prime equal to a, and all we did was just square, expand, isolating radicals, divided by 4, dividing by square factoring, rewriting, dividing by a squared to get to that 1, moving it to the side, and at the end you're going to get that form. That's what it is. Okay, this is where we got that form from. We got it from, that's why it's very special to the ellipse with plus. Okay, and that's super important. Now, the other super important thing, in your books, you have in some books they tell you if A is larger than B, then the ellipse is stretched horizontally, further in the horizontal direction. And if b is less than a, if b then more than a or larger than a, it's stretched in the vertical direction. I don't like that. I'll tell you why I don't like that. We want to keep it as quantity. Look at that. I want you to understand it's what's under x when you do x squared divided by a squared. A squared, it's the cross in the horizontal direction. This is where it crosses in the horizontal direction. That's why it's a when it's like this. And when you go like this, b squared, this is where it crosses in the vertical direction, okay? So in my mind, if you study with me, and this will help you to memorize less. We don't want to memorize any of that stuff. We want to say that if the quantity under the x squared is larger than the quantity under the y squared, then the ellipse is what? Is stretched in this direction. That's it. So, and this way it's a, right? And this way vertical direction under y squared is b. If the quantity under the x squared is larger than the quantity under y squared, meaning a is bigger than b, or b is less than a, without memorizing that. Now, if the quantity under what? Under x squared, I keep it under x squared, is smaller than the quantity under y squared, then it's stretched into the vertical direction. For me, all I did, I move, when it's in the vertical direction, I move the a and the a square under the y. Why? Because this is how it crosses this shape in the vertical direction, this one. That's why I put it under the y square. And I kept b minus less than a, because this one is smaller now. This is my minus b 0, and this is my plus b 0. This is my 0 and a, 0 and a, and this is my 0 and minus a. So I kept the a in the vertical direction, and I put it under the y square. Now, this is way easier, because that will, when you think about it as a quantity that crosses the shape in the vertical or the horizontal direction, first you understand what you're drawing. Second, you understand where the a falls, where the small a, where the small b falls, where is your major axis, where is your minor axis. And most importantly, you don't need to memorize if a is larger than b, if b is larger than a. Let me go to the board and show you the other way an ellipse, a vertical ellipse, and with a shift. Let's try to make a shift with that. Let's see what we can get with that, with a shift, okay? So let's go to the board and draw it in the vertical direction now. So let's say, let's keep that in mind. I want that to always be with you now. We're not done with them. B squared equal a squared minus c squared, okay? Now, in the vertical direction, what did I say? I said the quantity under the x squared, okay, is less than the quantity under the y squared. So I moved my a under the y, and I put my b under the x. If it's with numbers, it could be something like that. X squared divided by, I don't know, 25 plus y, or y minus 2. Let's make it h and k. Y minus 2 squared divided by 36. Yeah, we can do something like that. I think equals 1. Okay. So in this situation, your a squared is what? It's 36. Your a is still 6. Your b squared is 25, and your b is 5. And your b is still less than a. You don't need to memorize if a is bigger than b or b is bigger than a. Just stick with what I'm telling you with the quantity. This will make it, actually, you will grasp it better. You will understand that whatever is under that x squared is where the crossing in the horizontal direction happens, and whatever is under the y square is where the crossing in the vertical direction happens. This way, look at that. The A now is here. If this is the origin, this is 0 plus A, and this is 0 minus A, right? And this is minus B, 0, and this is plus B as coordinate 0, okay? And your F now is here. Absolutely, yes. Your F's are going to be here. And they're going to be in the form of what? They're going to be in the form of, again, 0 plus C and 0 minus C, okay? 0 plus C and 0 minus C. So it's a flip of the ellipse. Now the ellipse is vertical, okay? Think about it as quantity under x squared being smaller than the quantity under the y squared. Okay, now if you have h and k, what do? Basically, if you have h and k, that's like this. Here, let's do a quick one. In the vertical direction, h and k, it's not at the origin, okay? If you have something like that, if let's say this is the x and the y. Okay, if this is your x and y, and this is your h and k, then you center, okay? So this is your new center. You're going this way. Okay? Something like that maybe, okay? And then maybe something like that. And maybe the F's are here, F and F prime, and you go like this, okay? I'm sorry, it doesn't look that great, but you got the idea. Okay, now, with the HK, what do I get? I get, yes, H plus B here, and then K. Okay? H plus B, because I still have the B. Look, where is the B? This is the B, right? The B is from here to here. And this is the H. So H plus B, and then it's the K. It's the same K. How about on this side? Yes, H minus B. So H minus B, and then the K. Okay? How about up there for the major vertex or vertices? I got the same H, and I got K plus A. The A goes with the K, with the Y coordinate. The same way we did with the parabola, the P goes with the Y coordinate in the vertical direction. And the P went with the X coordinate in the horizontal direction. Here, because this is in the vertical stretch vertically, it's the B that is going to go with the H, and the A is going to go with the K. So this is H, K minus A here. Okay? Now, for the F, for the foci, what do we have? Again, H stayed the same, K plus C. So this is H, K plus C. And how about this one? K minus C. Yes, that's it. H, K minus C. Okay? So the A and the B, depending, you don't need to memorize any of that, but you need to conceptualize it or be able to conceptualize it. Once you understand that the quantity under the x squared is less than the quantity under the y squared in the vertical, you put the b under x, so this is minus b plus b, and then you shift your minor vertices according to the h, so plus b minus b, you keep the k, and a is under y, is where the cross in the vertical directions happens, and then the focus is also in the y direction, which with h, the x coordinate staying the same, k plus c and k minus c. Okay, so you need to sketch it on a piece of paper. Scratch your scratch notebook. Even if you're in a test, you will still have time to do that. That takes like 15 seconds to understand where your h and b and k. The only thing, like I said, so far, the only thing you need to memorize so far is this one. until we understand exactly where it came from. Okay? Now, let me move to y. Okay, so if you memorize this for now, if they ask you about c squared, what is c squared? Exactly, a squared minus b squared, right? And that works even if the ellipse is drawn this way. If the ellipse is drawn this way, see, this is c, right? And this is what? A, and this is b. It makes sense. C squared equal a squared minus b squared. But if you go with these ideas that, you want to memorize and what's in the textbook, if b is larger than a, okay? And then you keep this right here, and then you go like that, you will get yourself confused. Okay? This is the b, right? If you move it, like with the book, they make it like this. In this situation, it's a squared that is equal what? B squared minus c squared. And it's c squared in this situation equal b2 minus a2. So, see, you're going to start memorizing if you don't think about it as a quantity. Because here, and when they, in some textbook, they go with that, they have to do what? They have to put the a here. And that's going to make you memorize more. My whole goal is to make you memorize less. Don't think about it if a is bigger than b or b is bigger than 8. Keep it always as b smaller than 8. Remember that squish. It can happen also vertically. When we draw it like this, we can keep b here. Okay? As long as the quantity under x2 is a smaller quantity. So you move the b2 here. And you put the a2, a squared under the y, where the crossing in the vertical direction happens. That's it. Okay? I don't think this is very... there's nothing difficult here. The whole idea... we have some time for very, very minor things. I think we have 5 more minutes. Let's go back to our ellipse, and let's put it on the board because we're gonna need it for the next lesson. Let's draw it on the board. Do the first one. We're gonna before I stop with this lesson, and we go on a break. I'm just gonna prove to you why c equals a times e. Remember, the coordinate of the foci is c0 or minus c0. I'm gonna start by proving to you why c equal a times e, the eccentricity. Okay, but for that we're gonna need to draw the ellipse and keep it here with us. So here, let's again draw it at the origin, stretch horizontally to make it easy, and go just like that. And let's make this the center. What do I do here? Here, I'm sorry. Let me switch you back with me. Okay, let's call this F1. This time, let's call this F2. And let's call this O. We need to call the points now because we're going to derive some formulas. Let's call this A1. This is A2. Okay? And what else do we... We can take a P, we can take any point. But remember, if you take a P here, it's XY. We're not in R theta. Although we have a theta, which we're going to switch to when we go to polar, okay? Now we also have what? We also have our directrix here. Right? And we have our PM, shortest distance, the perpendicular, and we have PF. Look at PF1 is smaller than PM, so E is between 0 and 1. E cannot be negative. Okay? So far, so good? Okay, so this whole thing here is small a, and this thing here, this is B, this is A, okay? And the F1 is at what? Is at C0. and this is minus C0. Now, the only thing I want to do before I end this lesson, I want to prove that this C equals AE. So plus A times E0 and minus A times E and 0. Okay? Let's prove that, and then you guys can go on a break. Okay, let's switch back to the tablet. And all I'm going to do, you don't need to memorize this, because look, you can get to it from the regular definition of eccentricity. Equals what we just said. It's this PF over PM. And here we have PF1. Look at the board. We call it PF1 behind me. PF1 divided by PM. Okay? Now, if we keep expanding, this PF1 equals what? PF1 equals A1 F1 divided by A1 times N. What does that mean? Look here. PF1 divided by PM equal A1 F1 divided by A1 N1. And why is that? You tell me, why is that? Because, the P can be on what? On A sometimes. Remember, that's the idea. This is how we're deriving these things. So the P can be on A sometimes. So E is going to equal A1 at a certain point, F1, divided by what? By PM, A1, N1. What's N? This one here. A1, N, or N1. Okay? I'm going to call it N or N1. Okay? So instead of P, now it's right here at A1. So A1, F1 divided by A1, N. This distance here. Okay? That's all I did. No magic. Okay, let's go back here. So now I have this A1, F1. Look at that. A1, F1 equals what? E times A1N. Okay? And A2, F1 equals E times A2N. Where is A2? Look at the board again. A2, yeah, I have you. A2, look at this. I'm sorry, I keep losing. A2, E equals also what? A2, F1, A2, F1, A2, F1 divided by A2, F1. If this P could be here, this is D1. What's the D2? It's the other side. If this one, if this is D1, this is D2. A2, F1 divided by A2, N. This whole thing, this is N. A2, N. Okay? So again, P is moving around, and when it's at A1, A2, F1 equal, E times A2N, big A. Okay, now if you minus them, so if you do A2, F1 minus A1, F1, that's going to equal, you take E as a factor, A2N minus A1N. Okay? A2, F1 minus A1, F1 equals what? A2, F1 minus A1, okay, F1 equals what? Equals the distance between OF1 and OF2. So two of those, 2OF1. That's it. Equals 2OF1. Equals 2OF1s. Equals 2OF2s or OF1s. OF1 equal E. What's A2N minus A1N? That's, your 2A, your D1 plus D2 times 2A. So two of those C's are going to equal E times 2A. And if you do this, 2 and 2, your C is gonna equal A times E. We will repeat it in the next, after the break. But for now, this is how you get to C equal A